Okay, so in this video, we're going to be looking at example 4 for graphs of their functions, graphs of functions and their inverses. And on the front of those notes, we saw this definition for one-to-one, saying that a function is one-to-one if the inverse of the function is also a function. So before we take a look at these two examples on the back for one-to-one functions, I just want to go over here to Desmos real quick so that we can take a look at what we mean by one-to-one functions. So if I start here with just a basic parabola, so y equals x squared, right? Remember that for a graph to be a function, it has to pass the vertical line test. So everywhere that I would draw a vertical line, it can only intersect at one point, right, on that graph. And that's true of this parabola, the parent graph of the quadratic function. It passes the vertical line test. So my original equation, y equals x squared, is a function. Now, if you recall from example 3, in order to create the inverse, we switch the x and the y because inverses have symmetry over the line y equals x. So to graph the inverse in Desmos, I'm just going to switch the x and the y. So instead of y equals x squared, I have x equals y squared. And there's my graph of the inverse. Now that inverse graph, it has symmetry over the line y equals x, right, like we talked about in examples 1 and 2. So this is the inverse, but notice the inverse fails the vertical line test. So the inverse of the y equals x squared is not a function, and that means that y equals x squared is not one-to-one, right? In order to be one-to-one, the function and its inverse, right, have to be functions. So y equals x squared is not one-to-one. Okay, if I change this to y equals x, let's do y equals square root of x. Okay. And then I'm going to change the x equals square root of y, right? So now I have my original function, the blue here, which passes the vertical line test, and my red, its inverse, also passes the vertical line test. So this equation, y equals the square root of x, is a one-to-one function because both the original and its inverse are functions. They both pass the vertical line test. Now we don't want to have to graph the inverse every time we want to decide if a function is one-to-one. So what we do instead is we think about something called the horizontal line test. So if I go back here to my original parabola, y equals x squared, right? It passed the vertical line test, but its inverse, x equals y squared, its inverse failed the vertical line test. Now, if you can visualize from this picture that the inverse failing the vertical line test you would notice that that would happen if you thought about drawing a horizontal line through the original graph, right? So if I hide this inverse graph and I just think about, instead of the vertical line test, if you visualize a horizontal line going through, see how a horizontal line would hit in more than one place? That means that its inverse, right, would fail the vertical line test. And so rather than having to graph the inverse every time, we can use the horizontal line test on the original graph to see if it's going to be one-to-one or not. Okay, so when we look at the notes in example 4, that's what we're looking at, the horizontal line test. So if f of x fails the horizontal line test, its inverse is not a function. Okay, and to be one-to-one, the inverse has to be a function as well. So to be one-to-one, the graph of the function has to pass both the vertical and the horizontal line test. So when I take a look at example A, 1/6 x plus 2 to that quantity to the third power minus 1, here's the picture of that graph, right? And it passes the vertical line test for sure. Does it pass the horizontal line test? So when I look at the graph here in the center, this is the part that's a little worrisome because it looks like it's straight there, but that's just because of the nature of this TI-84 graphing calculator window. The pixels are squares, so it can't make a smooth continuous curve through that spot. But I know that if I were to put in an x, a value for x, I'd always get out a different y value. So that means that it's a very shallow slope here, but these are all different x and y coordinates in through here. So it does pass the vertical and the horizontal line test, and so f inverse of x is a function. Okay, so that's a yes because it passes the horizontal line test. And then is f of x 1-to-1? That would also be a yes because it passes the vertical and the horizontal line test. Okay, so f of x equals 1/6 times the quantity x plus 2 cubed minus 1 is 1-to-1. Okay, now when I look at example B, I'm looking at this polynomial negative x to the fourth plus 3x squared plus 2, and its graph passes the vertical line test. So B is a function, but is its inverse a function? So if f inverse of x is a function, it would pass the horizontal line test. But I can see here when I draw a horizontal line, I hit 2 points on the graph, and so the inverse is not a function. Okay, if the inverse is not a function, then the original f of x is not 1-to-1, right? In order to be 1-to-1, it has to pass both the vertical and the horizontal line test. Okay, so down here at the bottom, the turn and talk, why is graph A the most commonly missed question on the quiz? That has to do with this region here on the graph that it visually appears to be horizontal, so that it looks like it would fail the horizontal line test, but you have to remember that that's just an issue of the pixels, right, on the screen, and that this does, for every x, have a different y that goes with it, and so that is a function through here, right? It's not going to fail the horizontal line test because each x has its own unique y value. Okay, and that brings us to the secret question for this lesson on graphing inverses. And for the secret question, you're going to get some separate paper and then use graphing technology, either a graphing calculator, or you could use Desmos or GeoGebra online, but use some piece of graphing software to determine which of these functions are 1-to-1 and which are not. So you're going to want to graph each one of these functions, A through E, and determine if it is or is not 1-to-1. So for each of those, make a rough sketch of the graph on your paper, and then you can indicate which ones are 1-to-1. Make sure that you upload a copy of your secret question answers to the assignment Dropbox along with your notes at the end of the lesson.